Assalamu alaikum students. My name is Sadaqat Jan and I'm your instructor in SE102 Introduction to Programming for Fall 2020 semester. Dear student, before discussing our new topic, let's have a look at our previous week's topics. Contents of today's lectures are Introduction to Functions, Function Definition, Function Calls, Function Parameters and Arguments, and then we will discuss return statement, the rule of return statement. Then we will discuss the function prototypes and how to write prototypes for different functions and what are the role of the prototype in the functions and code. Here we have one of the many definition of the function. A function is a section of C code that performs a specific task and optionally returns a value to the calling program or function and receive values from the calling program. So a function can return a value and can receive one or more than one values. But remember, it can return only one value to the program or to the calling function. We will see and we will demonstrate how we return values and how to receive the values from other function or program. So basically a function is a section of C code. So this section means it can be one statement or it can be uh, as many as you want. It depends on the task. So a function is usually designed for a specific task, and there are two main categories of the functions we'll discuss on the next slide. These are the two categories of functions: predefined functions available in C, C++ standard libraries such as stdio.h, math.h, string.h, conio.h, etc. And then user defined functions, functions that programmers create for special tasks. A special task can be any task, it depends on the requirement of the programmer. Here we have some functions characteristics. Unique name, that means every function should have a unique name in a single program. It performs a specific task. Again, that specific task depends on the requirement of a programmer or user. Independent, that means a function can perform its task without interference from or interfering with other parts of the program. So every function is executed independently. Functions may receive values from calling function. Calling function can also pass values to functions. Functions may return a value to the calling program. Again, it can return only one value. The call function may pass something back to the calling program. So we'll demonstrate all these characteristics through examples. C program does not execute the statement in a function until the function is called. So if we have three functions and we haven't called them from other functions, so those functions will not be executed. So that's quite obvious and clear that it will not execute the statement in a function until that function is called. But when it is called, the program can send information to the function in form of one or more arguments, although it's not mandatory and it depends on the requirement of the task or programmer. Argument is a program data needed by the function to perform a task. We will demonstrate the list, how we create and how we send data, and how we use those arguments. When the function finished processing, program returns to the same location which function called the function. So the control is basically returned to the calling function or to the calling program. A function can be called as many times as needed. It depends on the requirement. It can be called in any order, provided that it has been declared as a prototype. That's our next topic. We'll discuss the what is prototype and defined. So basically, for next few example, we will follow the same sequence and we will execute them in order. And after discussing the prototype, then we can change the order of execution. Here we have our first function, and the name of our first function is asset. How we name the function, it depends on our task, but we have to follow the same rule, the one we use for variable. It shouldn't start with a digit and space and other special characters, etc. So in this function, this is the name of the function and this is body of the function. Inside this body of the function, we have one statement. It can have more than one statement depending on the task of the function. We don't have a specific task, but we just want to demonstrate how we create function, how we call that function, and how the control is passed in between those functions. So to demonstrate those basic concepts, we have this function and we have our main program here. Inside our main program, we have only one statement, and basically this is asset function calling. So this is call function call. We are calling this function. So when the program execution is started, then this function is called. So the control will go to the asset function. Inside the body of this function, we have only one statement that will be executed. And after the execution of this one statement, and after completing the execution of the whole body of the function, the control will return to its previous location. This is the previous location of the control. But here we don't have any other statement, and it's the end of the program. So the program will end here and hello will be printed. So that's very simple. So I will repeat the execution, uh, the flow of the execution actually. When we start executing the main program, the control will be passed to asset function because we called the asset function. So the control will go to the asset function here, and inside this body we have one statement, so that will be executed. After the execution, the control will go back to the calling function. This is the calling function. This is the called function, and this is the calling function. So the control will go back to the calling function. Inside the calling function, we don't have any other statement. So that will be the end of the program. So it's very simple. So the same function with a little bit changes in the body of the function and in the main. And remember, we have to write the asset before the main function, because if we write the main function here, so the compiler will not be aware of the asset function, because the code, the definition of the function is written after the main function. We will address this issue at the end of this lecture when we use the prototypes. Uh, Till that, we should follow the same sequence, and we will write the definition of the function. This is the definition of the function. This is the name of the function, again asset, and this is body of the function. And inside the body of the function, we have three statements now. Uh, and we have main program, and you can see that this is also a function. Main bracket, this is start, this is end. So if you remember, at the start of the semester we discussed that we will not discuss what is main. So main is actually a function. What is the difference between this main function and other function? Basically, the computer, the operating system will give control only to main function. If we have more than one function in a program and we don't have the main function, the program will not be executed. So this is the entry point, or this is the main gate actually to start the execution of a program. So when we start execution of the program, then and this is the body of the main. So we have four statements, and actually we have called asset function four times. So first time the asset function will be called, and then inside the asset function we have the three statements. So it will print a b c. So a b c, let me use the pen here. So this is for the first call. Then this is done, then again the control will come back here, and again we have asset call. So again the control will come back and we will execute a b c. So this is the second call. Again, after execution of ABC, this is ABC, and the control will come back here. Again, we have a third call. Again, this is ABC will be printed, and the fourth statement is another call to the asset function, and this is the uh, fourth group of execution. So basically, that's the flow of execution for the functions. So you can see when we call asset, the control will come here. It will execute this statement, then this statement, then third one, and after execution of the third, the function ends here. So the control will come back here. And again here, it's the end of the program or end of the main function. So that's the end of the program. So that's the output of the program. Another example, this time we have some statement in the main program and the same asset function here. So you can see here we have two statements and the asset function here, this one, and then we have one statement, two, three, four, five statements in the main program or in the main function. This is also a function as we discussed earlier. So the first statement is to call the asset function. So asset function is called. So the first statement in the main function is asset function call. So the control will come here and A will be printed. This one, and then B is printed. So we are done with these two. Then after this the control will come here. So here we have another statement, this one, printf, and this statement is executed. After the execution of second statement, we have another function call. So the control will come here and is printed, then B. After that, the control will come back here at this point, and we have this printf statement. So this is executed, and then we have the last one and this one. So that's the output. So that's actually the flow of the execution. So it's really important to understand the flow, how we control the flow of the execution and how we call those functions. So it's very simple. These are simple functions. We are not passing any values to the function. We are just calling them, and the control comes back to the uh, calling point, or to the calling function, or to the calling program. Let's have another example. Another example, this time we have four function in this program. This one, A, B, C, and main. So these are the names, the A, B, C, and main. So we have four functions, and this is the definition of A. Colored black, that is colored red and blue, and main function or main program. We call it a program because that's the starting point, or that's the main function. Okay, so here you can see that we are calling a function inside B. So this function is called by this function, or in other words, this function is calling this function. So this is function call here, this is function call, this one is function call, this one is function call. This is the function definition, function definition, function definition, and function definition. This is the function definition, and this is the body of the function. Body of the function, two statements. Body of the function, two statements. Body of the function, three statements here. So let's start with the main, and I have to use the pen. Okay, so the first statement, this is executed, then the control will go to A here, then these two statements executed, so we are done with this. The control will come back from this point to C, and we are calling C, so the control will come here. So this statement will be executed, and you can see this one. And then after the execution of this statement, we have another call to B. So from C, now we will go here, right? So here we have one statement, so we'll execute this one. And the second statement is another A. So from here we will come here. So again, that is A, B. When we return from here, we will return here, and after returning, then we will return here, and then we will return here. So at this point, you saw here, and you noticed here that we are at the end of the function. So it returned from here to this point, and then from this point to this, and that's the end of program. So that's the output. So again, it's a simple function call just to show how we call one function. There are some more examples in your textbook, so you have to practice those function, and how you should practice your own functions also, and call different functions from other functions. So here on this slide you can see that this is main function try f underscore a. So this function is called, then execution, then b is called. So this function, the control will come here, and after execution, then the control will come here, and after the return statement here, the return is here. Remember, we haven't used the return statement, but the end of that curly bracket, it also work as the return statement. So the control will return with the return statement or without return statement. It can, the control will be returned. uh, it's not necessary to use the return statement. We will use in the coming slide, we will use the return statement, but till now we haven't used the return statement, and the control is automatically returned to the calling function, and that's the sequence. That's another example you can see here, this one, and that's another probably you will discuss this in the object-oriented programming, because we haven't studied the exceptions yet. So this is our relevant diagram, this one, the first one. Next we are going to discuss function parameters and arguments. So basically we will discuss and we will demonstrate how to pass values in between two functions. Here in this example, we have a function. The name of the function is square, and this is the body of the function. It has only one statement, and this is printf statement, and this is something new, and this is called the parameter. Uh, the parameter means that this function can receive integer, and whatever the value, whatever integer it receives, it will be stored on x. So this is the function. So if we want to call the square function, we have to pass an integer value, and again that integer value will be stored on variable x. And this is a kind of variable declaration also. Here this x is accessible only in this function, and this means that if I have a statement to print the value of x in this function or in the main program or in the main function, then it will show the compiler error, and the compiler will give you an error that x is not declared, because this x is not accessible here. So the scope of the x is only from here to here. Outside this block, this x is not accessible or visible. So let's have our example. This is our main function. It starts here, that's in here, and we have two variables, integer variables, a and b. The value of a is 5 and the value of b is 10. And here we have function calls 1 2 3 4 5. So we have 5 function calls, and these are arguments, because these values or these integers, these will be sent to square function, because you are calling square, and this will be sent to this function. So let's suppose let's execute this one. So when we execute or when we call this function square, then the value of this a, it will go and it will stored on x. So the output will be this one, the square of 5, because this x is now 5. So the square of 5 is 25, because x multiplied by x, or 5 multiplied by 5, so that is 25. So that's how this output or this printf statement will be executed. Now the second time when we call the square function, the value of b, which is 10 will go and that will be stored on x. So the value of x is now, for this statement, the value of x is now 10. So that's why the square of 10 is 100. When we call it for 11, the value of x here will be 11. So 11, the square of 11 is 121. Similarly for 4. And then we have expression, the argument, that means b minus 2, so 10 minus 2. So 10 minus 2 is 8. So that 8, that will this 8 will go, this 8 will go and it will be stored on x, and the printf statement, that will be the square of 8 is 64. So that's how the square function execute and receive the values. So basically, to the square function we can send any integer value or variable. So this is for example this one and this one, and yeah, these two, we are sending immediate values or integer values, and here we are using variable names. So we can pass variable names, the values of variables, actually not names, the values of variables, or we can directly send the integer values also. Now we have two functions here. The first one, the square, the same function which we already discussed on the previous slide. The name of this function is square, and then we have another function. The name of this function is sum. And as we discussed earlier, that this function can receive one integer value, and this function, it can receive two integer value. The first value will be stored on x, and the second value that will be stored on y. And that's the one statement here. That's the body of the function, and this is our main function. So inside the main function, we have two variables, a and b. The value of a is 5, and the value of b is 10. And then we have four statements and four function calls. This is square function call. This is sum, sum, sum. So basically we know that we have to pass one variable, an integer variable, to square. So the value of a, which is 5, that 5, it will go and it will be saved on integer x here, and then the output will be the square of 5 is 25, as we discussed in the previous slide. Then we have the second function, and here we can see that this function can receive two variables. The first variable will be stored x, and the second variable will be stored on y. Remember that this x and this x, they are two different variables, even though they have the same name, but this x is not accessible here. So if we print the value of x, so that will be the value of this x, and here this will be the value of this x. They are two different variables. This x is not accessible here in this function, or even here in this function, and same is the case with this x. This is not accessible here in this function or in this function. This x is only accessible in this function. This x is only accessible inside this function. So let's execute our second second call or second statement. This one, the value of a, which is 5, that will go and it will be stored on x, and similarly the value of b, that will be stored on y, and that will be the output. The sum of 5 and 10 is 15. In this second sum function call, this value, the first argument, this will go to the first parameter, which is x, that will be stored on x, and the value of b, which is 10, that will be stored on y, and this is the output of this statement, that will be this one. Similarly 100, it will go and it will be stored on x. In the second argument, it will go and it will store on this, and the output of this statement, that will be the output. So that's how we call a function. You can see here in the second call that we have immediate value and variable. So, and here in the third call, both parameters, both arguments, they are numbers, immediate values, 100 and 200. So we can send any combination. It depends on the requirement of the program or user. Okay, so it's the previous example, the one we discussed earlier. We send a variable value to the square function, and the result is printed here in the square function. Similarly, the value is sent to square function and the value is printed here. Similarly, this one, and we print the square in the square function. Similarly, this one, we send a value and the result is printed in the square function. Now we will try to write a code. We will try to send a value to the function, and then the function will calculate the square, and it should send back the result to the main function or to the calling function. So in this case, we are sending a variable to a function, but this function is not returning any value here. On the next slide, we will try to write a code where a function will try to send back the value to the calling function. So let's try that. So this is the return statement. Basically, this return statement, or this one return statement, it actually return the control and the value. Whatever the value is enclosed in the bracket, that will be returned back to the calling function. For example, if this square is called from this function, so this z will be returned to the main. If this square function is called from the sum, then this z will be returned to the sum function. So it depends that this from which function or from which part of the program this square function is called. Now let's try to execute this program. We have three functions now: square, sum, and main. This function, it receives integer value and it return integer value. How we know that this is integer? Because that is integer. So it receive an integer value and it returns back an integer value. In the second function, where we receive two integer values, it again return one integer value. Remember that return statement can return only one value. However, a function can receive multiple value, and we will discuss different combination of the arguments and parameters. So let's execute this one. Now in this program we have 1 2 3 4 5 6 variables, integer variables. A is 5, B is 10, M and N, L. So here we are calling square function, but we have to write M assign. This is the assignment operator, because this function will return an integer, so we have to receive this integer on some variable. So we are receiving it on M, and then we are printing the square of this, and this is M. So you can see we send A, which is 5. That 5 is stored here on X, and then z is equal to x multiplied by x, which is 25. Then 25 is stored on z, and this 25 is returned to here, because square is called from the main, so that will be returned here. So that 25 will be stored on M. So the square of 5 is 25. So you can see that this message actually, this 5 is sent to the square function, and that is this one, and then the square of the 5 is 25. That is calculated here, and it is returned by this return statement, and this 25 is stored on M, and M is printed here. So that's how it works. We can receive this 25, this z value, or the return value of the square function, which is this one. We can receive it on M, N, A, B, whatever, but it should be integer. Why? Because this is sending or this is returning an integer value, so we have to receive it on integer value. Let's suppose if it returns a float value, so we have to receive it on a float value. In this case it is returning integer, so we have to receive it on integer. So let's demonstrate how it works. So basically let's execute the right side. So a is stored on x and the value of z is now 25, so 25 is returned. So let's continue the execution of the program. There was some mix-up on the previous slide, so let's demonstrate again here. So the value of a, that will be stored on x, and then the value of z is now 25 because the value of x is 5. So 5 multiplied by 5, 25. So z is returned and it will be stored on m, and here you can see the output of this statement. So it's very simple. Now let's execute this statement. The on the right side, this sum function is called, and a is sent, and that will be stored on x, and b it is stored on y, and the value of a is 5 and the value of b is 10. So z is equal to 15. 15 will be returned and it will stored on k here, and this will be the output. So that's how this program will be executed. So basically we should receive the return value on a proper type of the variable. Here we have three functions: square, it receive integer value, and it return integer value. Here it receive three integer value x, y, z, and it returns float value because s is float and it returning as. Remember, if the return type is not mentioned, like this one, we haven't mentioned any type here, the return type. This is the return type, name of the function, and list of parameters. These are arguments, three parameters here. So if it is not integer, then we have to mention, because by default the compiler will consider that this is integer and this is integer, so we don't need to write the integer. But if it is not integer, like here in this case the return type is float, so we have to write the float. And so this is the return type, the name of the function, and then the list of the parameters. So we have 1 2 3 4 integer variables and one float variable. So here we need to call this square a again. So it's the same example, the one we discussed on the previous slide. So the square of 5 is 5. For this one, the integer, and integer, the value of integer, that will be sent. Remember, the value of m is now 25 because of this function call. So 5, 30, and 25, that will be sent to this function, and here we will calculate the average plus x plus y plus z, and then divide by 3, so that will be s, and the s is returned to the calling function. This is the calling function, this one, and that will be stored on k. So in other words, we are receiving whatever this function sends back. So this function let's check what this function send us. This function, the average function, it send us the float value, and we are receiving the float value on the k variable, and that will be the output. So let's use some markers here. So a that will go to x, b that will go to y, m that will go to z, and the value of s that will be returned to k, and that is the output. So simple. So we have 5 functions on these slides. We will discuss them one by one. The main purpose of this slide is to demonstrate how we call different types of functions with the different types of return values and list of parameters, arguments. So this is the first function. The name of the function is xyz. The return type is float because it is returning 3.3. Whatever it receives, that will be stored on p, and it will only receive character variable, and that will be stored on p, and it will return 3.3. So it has only one statement, which is this one. So this is a function number 1. Then we have another function. The return type is float. Name of the function is abc, and it can receive integer value. And inside this function, we have a float variable v5 is equal to 1 this value, and it will return v5. So whatever it receive, integer is received, it will return v5. So again, the return type is float here. Then we have third function. It returns the character variable. The name of the function is ab3, and it can receive 2 float variables. The first float variable will be stored on a, and the second will be stored on b, and it will return a character value, and this value is t. So that's why this is the return type. The fourth function, it will again return a character variable, and it will receive a character. So this ab4 function, it receives a character and send back the character. So whatever it receives, it will send back. For example, if you send here capital A, it will send you the capital A. So it will do nothing. It will receive the value and it will return as it is. So this is the fourth function. So here in the main function, or in the main program, we have lots of variables here. We have two character variables, actually 3 character variables, a, b, and m. Then we have character variables e. The value of e variable is w, and the value of f variable is capital S. Then we have 2 float variables, g. The value of g is this, and the value of h is this. So let's call xyz. So when we call xyz function, we have to receive the value of xyz on a float variable, because xyz, here you can see that xyz will send back a float variable, so we have to receive it on a float. So we have 2 float variables, g and h, so we can use any of them, g or h. So g, then xyz function is called this one, and we know that this function will receive a character variable, so we will pass a character variable. We have 2 characters, we can pass e or f, whatever, or we can send immediate value, whatever you send, it will return the float. So we are passing w. So w, this one, this is w because e is, so this e that will, or the value of e, which is w, that will be stored on p. It will be received here, but it will do nothing here. It will return only 3.3 float. So it will return 3.3. This 3.3, that this will be saved on variable g here. right? So first call, so g is 3.3, so you can see here. Then the second function is called, so again we should receive the float value on g, or even you can use h, whatever, and it will accept integer value. So you can pass a, b, or m, whatever you pass here. So a, b, c, then the value of b, which is 30. 30 will be stored on r, so the value of r here, it will be here in this function, the value of r will be 30. We have another variable declaration here, v5, and the value of v5 is this, so v5 is returned 11.1, that will be returned. So this v5, this will be stored on g. So again we are printing this g, so g is here, this one, right? Then the third function call, the name is ab3. So we know that it will return character, so we should receive the value from ab3 on character variable. This is character variable, so we are using e, you can use f. And we know that we have to pass two float variables, so we have two float variables, you can pass gh or gg, or even values. So the value of g, that will be stored on a, and the value of h, that will be stored on b, and it will return t. So the capital T, that will be returned, and it will store on e. When we print e, it will print this, and e is equal to e. This is the fourth function. F, the value of f is s, it is a character, it is receiving a character, so we are sending a character. So that f, the value of f, which is s, that s will be stored on r7, and then we are sending back r7 to e, and then this is printed. So let's demonstrate this one. So the value of e, that will go to p, and this 3.3, it will come to g, right? Similarly, the value of b will come to r, and this v5, it will come to g. Similarly, g will go to a, and h will go to b, and this t, it will come to e, and the value of f, it will go to r7, and this r7, it will be returned, and it will be saved on, and these are the outputs. So let's revisit the definition, what we studied so far. A function is a section of C code that performs a specific task and optionally returns a value to the calling program or receive values from the calling program. For example, the square. So the square function was a part or a section of code, and the purpose of the square function was to calculate the square of the value and print it. Similarly, the sum function we use, similarly the average, or others. And we saw on the last slide that a function can receive 1, 2, 3, 4, it doesn't matter, and any kind of any type of variables, and it optionally returns a value. Remember that return statement or a function can return only one value. Unique name means that if we have a function square in our program, so we cannot have another square program in the same function in the same program. So every function should have a unique name. It's perform a specific task. The task depend on the requirement of the program, or requirement of the user or a programmer. Independent, a function can perform, uh, you have noticed probably on the one of the example that where we use the same variable name x in two functions. So a function can perform its task without interference from or interfering with other part of the program. So you saw that one x was not interfering with the other x variable of the second function. Both were independent. Functions may receive values from the calling function, or calling function can also pass values to a function, which may return a value to the calling program or function, and the called function may pass something back to the calling program, as we discussed in the case of return statement. So it can send back using the return statement, and it can receive the uh, values using the parameter list and the list of the arguments. C program does not execute the statements in a function until the function is called. Remember that uh, if we have four functions and we haven't called any of them, those function or the statement within those functions will not be executed unless you call them. When it is called, the program can send information to the function in form of one or more arguments, although it is not mandatory. Uh, we demonstrated the argument passing functions like in sum or like in average or square function. Argument is the program data needed by the function to perform its task. Like in the square function, x was the argument. When the function finished processing, program returned to the same location which called the function. Uh, Remember, when we call a function square, the control was sent back to the main function. So that's the return of the function call. Function can be called as many times as needed. You can call square function. Remember, we called square function three times, or in some cases we call that function four times. So it depends on the requirement. It can be called in any order provided that it has been declared. Remember, we used to write the definition of those function before the main function because we didn't discuss the prototype, and prototype is our next topic, and we will see how we write the prototype. It's very simple. So prototype, a function prototype is simply the declaration of a function that specifies function's name, parameters, and return type. So basically these are the three information. When we declare them, the compilers know that the definition of this function is available somewhere in the program. So you can change the order of the functions, or you can write the main function first and the other functions also. So a function prototype gives information to the compiler that the function may later be used in the program. So it's just information for the compiler, so the compiler will not be confused. It is very simple how to write a function. You should write the return type, function name, and list of parameters, and semicolon. So that's the prototype. But remember, we have to write these declarations. This is called function declaration also, or function prototype. They're the same. So function declaration or prototype, we have to write these before the main functions, so the compiler know at the beginning. So we will use the same example, the one we discussed on earlier for the function calls and returns. So this is the function. We will write the prototype for this function. So this is the return type. So this is the return type. Name of the function, and what type of value it receives character, so we will write character. It's optional if you want to write the name of the variable, or if you do not want, so that's enough to write the type of argument only, and then the semicolon. Similarly for the second, return type, name of the function, and the type of the argument. Return type, name of the function, and we have two um, types, variable types, float and float. So here we will write float and float, and here character, return type, name of function, and parameter. So the type of the parameter is character, so here is it is character. So character, name, and character. So these are the prototypes for these functions. Now you can write this function after the main function, or you can write this function first. It doesn't matter. Now, as if you remember, in the first or second slide we discussed that we have to write the definition of the function before the main function. But if we have the if we have the prototypes of the function declaration, then we don't need to follow the order of the functions. So that's it about the functions. If you have any question, you can post those questions on the wall, or you can send through email. I will try to answer your questions. See you with the next topic.